In Seoul, Korea, an artist group collected photographs of clouds that looked like human faces. They showed these photos to an AI face detection program, which analyzed the shapes and reported, with high confidence, seeing actual human faces in the sky. This glitch happens because an AI is taught by example. If the millions of photos used to train the system are heavily skewed toward a specific demographic, like lighter-skinned males, the software learns to prioritize those specific features, hallucinating them even in random noise. Spotting faces in the clouds reveals a major vulnerability. We tend to assume machines are perfectly objective, but their logic is built on the specific examples we choose to show them. This vulnerability has significant consequences for people. In Hindi, the term for doctor is gender neutral, yet translation software often converts that word into the English masculine pronoun he. This issue is even more pronounced in facial recognition technology. Researcher Joy Boulamwani discovered advanced software routinely failed to detect dark-skinned faces entirely. The system only recognized that a human was standing in front of the camera when she put on a stark white mask. These translation errors and recognition failures demonstrate that software functions exactly as it was trained. The AI is simply following the unbalanced patterns it was given. To fix this, we have to understand how an AI learns. These systems don't possess human reasoning. They identify statistical patterns within massive datasets. This historical data shows 55 boys played cricket, compared to only 15 girls. The AI converts this imbalance into a rigid mathematical rule, associating cricket exclusively with boys. When a new girl asks for a recommendation, the AI denies her request based on past patterns. The system cannot evaluate her individual talent or interest. It is simply enforcing a statistical average from the past. In engineering, this is known as garbage in, garbage out. When these systems are used in the real world, historical numbers can become weaponized. Consider a corporate hiring algorithm trained on a company's past hiring records spanning several decades. Because those historical records primarily featured male engineers, the AI learned to automatically downgrade resumes from female applicants. The algorithm didn't invent these prejudices, it just automated them, turning a company's historical hiring habits into a highly efficient, high-speed filter. Without active intervention, a biased dataset transforms a neutral mathematical process into a permanent engine for discrimination. If AI acts as a mirror reflecting our past, we have to actively curate what it learns to build a different future. This requires building diverse, representative datasets. We must ensure that minority groups are equally visible in the data before the machine begins its training process. We also need transparency. This means rigorously auditing AI systems for bias, both before and after they are deployed. Fairness and automation is not a default setting. It requires constant human oversight in engineering. This leads to the most important requirement: human accountability. AI is a tool meant to assist human judgment, not replace it. In a hospital, an AI system might analyze patient data and flag someone as high risk. A doctor must review that recommendation and take final responsibility for the outcome. The future of automation depends on humans taking ownership of the data we leave behind, ensuring that our machines reflect our shared values.